Okay, let's get started. Good morning, everyone. Welcome to this Gradle Bootcamp workshop. My name is Peter Niederwieser. I'm an engineer for Gradleware, and I'll be spending the next 2 slots with you to getting hands-on with Gradle. You already have all the slides if you want them yourselves on the website, but we need quite a bit of software for those of you who want to do the labs. And this is like 100 meg zip, and that's why I have it on those sticks. So if you could just copy that one zip file while I'm doing the introduction, and then pass it on. And by the end of that, everyone should have everyone you need. It's all in one zip file. So just go to one zip file for your if you want to do the labs. Okay, before we get started, I'd like to get to know you a little bit better. So who of you, by the way, I'm not a native speaker, you probably know it by now. I'm from this little country called Austria, which sits right in the middle between Germany and Italy. But I do my best to make myself understood. So who of you has ever tried Gradle before, played around with it a little bit? Wow, that's lots of hands. Okay, I have to adapt my question then. Who of you is actively using Gradle? Oh, a couple of people already. Okay, the idea of this workshop is in the next 3 hours to give you a whirlwind tour to get your hands dirty. You don't necessarily have to understand everything like to the bottom. We have lots of other sessions today and tomorrow that go into more detail, but we'll jump around a little bit and hopefully we'll show you some basic and also some exciting and more interesting features about Gradle. We have 3 hours. Whenever you have a question, just ask. We should have time for some questions. And especially if you will always do a little bit of presenting and a little bit of lab. So during the labs, I'm there. We require a lot of people, but I'll do my best. So if you have a question or a problem during the lab, the first lab will be to getting Gradle installed. If you have a problem, just let me know immediately, and I'll do my best. Okay, so the zip files are moving around with the Gradle distribution and everything. That's the fastest way, I think, to get it installed. Just copy the zip file from the USB stick and pass it on. And then we'll have a separate lab just for installing Gradle to get started. Okay, so the workshop, you have the slides. I'll probably put up the material as well. It's pretty large, but I'll find a way to upload it to the website if you want it for later reference. And we'll do lots of labs, and please ask questions. For the labs, the pairing is encouraged, so usually that's the best, from my experience, I've done this a couple of times, the best way to make progress is pairing. That always works best. The pairs always win the race, at least in my workshop. I'll show the exercise after the fact, the solution, sorry. Actually, I decided not to distribute them because I had some bad experience with that, but I'll show the solutions and they'll be available online afterwards so that you can refer to them. And the first lab, that will be the setup. So idea is to go a little bit beyond just being a Gradle user. So this is not a Gradle user workshop necessarily, but you will play build master a little bit, as good as we can in 3 hours. And we'll do some build authoring. And of course, we also use Gradle as a build author. And if we really have some time left, I also have prepared some of the very latest features, Gradle 1.6. So if we have time, we'll fill that with interesting new stuff. Okay, so let's get started. While the zip files hopefully are moving around, let's talk a little bit about Gradle the project for those of you who haven't heard about Gradle before. So Gradle, it's a JVM-based build automation tool. And build automation tool we mean in the really generic sense. It's not just about building a jar or a warp or an ear. It's really about automating any workflows in your enterprise. So we have clients that, of course we have those clients that build the jars, wars, ears, but we have clients that publish their static websites, generate them with Gradle and publish them to the web servers with Gradle. Generating documentation, anything that needs automation in the enterprise, we try to make Gradle a good toolkit for that. We are JVM based. We are starting to support tools outside the JVM ecosystem like C++, but Gradle itself is implemented in Java and Groovy, so runs on a JVM. Our core is implemented in Java. I really like Java for that, safe and fast. And the outer layers of Gradle itself, if you're interested in that, are sometimes implemented in Groovy. The higher layers, the build script language, they are generally implemented in Groovy, and the core is generally implemented in Java. Of course, we are all open source, Apache license, and you probably know Gradle.org by now. And our nice logo, hopefully as well. Gradleware, that's the company behind Gradle. And we employ most of the developers that work on Gradle. We provide consulting, training, all kinds of services around Gradle in particular, and build automation in general. We are distributed over this world. So these are where our developers are located, which is really convenient because for our weekly meeting, no matter when we do it, it will always be midnight for someone and 6 o'clock in the morning for someone else. And we try to optimize that, and so we came up with Germany, Australia, UK, Poland, Austria, Canada, and the US. That's what we have right now. And it's pretty much one developer per country. Gradle Project, if you're interested in the Gradle source code, if you want to help us out, want to get really involved in the code, everything is up on GitHub. If you have questions or suggestions, best way is forums.gradle.org. That's, so to speak, our mailing list. We don't have a traditional mailing list anymore, but we have forums.gradle.org, and usually we try really hard to get you a fast and good answer. So all of the Gradle core developers are monitoring that forum, and we'll try to help you out if you have a question. We release quite often, every 6 to 8 weeks, so that allows us to innovate quickly. We do a lot of testing, so by now I think we have around 8,000 tests in the Gradle codebase. Many of us are in some way involved with some testing framework, like I do my own open source testing framework. Luke Daly does his own open source testing library, so we are all very keen on testing, and that's what we do for Gradle as well. Okay. In terms of documentation, that's an interesting slide. If you are stuck, where can you find more information about Gradle? There are really 3 good sources of information. First one is the user guide. If you want to have the comprehensive answer, then go to the user guide. That's all up on Gradle.org. There's also a PDF version, and that you can really, that allows you really to understand what's going on. There's a single page HTML version. I find that very handy because I often use the simple browser search to search for keywords in the single page HTML. And surprisingly, if you apply that trick, you open the single page HTML and look with Control F, search in there, you can answer 75% of all questions answered on the forums just by extracting some keyword, searching in there, and pasting the answer. So we wish this trick would be better known, then we wouldn't have as much work on forums. The next thing is when you're authoring a build, you're really in the middle of authoring a build and you want to know something about the Gradle build language, about the things that you write in your build scripts. Then the best starting point is the build language reference. You can think of it as a Java doc, but higher level, a Java doc for the Gradle build language. And so if you want to know how do I set the version of my project, or how do I declare a dependency, and what's the syntax, then the best thing to do is to go to the Gradle build language reference. And if you need even more information, this build language reference will sometimes link into the Java doc and Groovy doc. So we have regular Java doc and Groovy doc as well. And if you need more details, you can link from here to there. You can travel down. And last but not least, a little known fact, Gradle distribution, and you'll all have it on the zip. So you'll all have the Gradle distribution by now. This includes, first of all, the user guide and the build language reference, and it includes many samples, sample builds. Like, how do I get started with a Java build of a core, or how do I get started with Scala or Groovy or OSGI, or importing into my IDE. There are lots and lots, many dozens of sample builds in the full Gradle distribution. So that's a good another good source of information. Want more resources? Forums, Gradle.org is always a good place. From time to time we have free webinars. We didn't have many of them recently because we were piling up for the conference to have good and new content here. But generally we do webinars from time to time. There are a couple of books out. There's a 3-part O'Reilly series. The first part is this book is a very gentle introduction, just 75 pages or so, but it's 3 parts, right? And they're currently working on the 3rd one. There's also a book coming out, Gradle in Action by Manning. That's also in the review phase, and we are part of that. That's looking to become a really good book as well. Okay, so in terms of Gradle releases, a big milestone was for us pretty much a year ago. June 11th, we released Gradle 1.0. That was an important milestone because it's our baseline for backwards compatibility. So we take backwards compatibility really seriously. We are a build tool. We love to use all the latest tech, but we also understand that for a build tool it can't break every night, right? So if you find something in Gradle 1x that works in Gradle 1.0 but not in 1x, it's a bug. It's as simple as that. And you please let us know on the forums, and we'll try our best to fix it. So that's the general idea. We are fully backwards compatible with 1.0, but we aggressively add new features on the side, even in 1x. So we don't wait until Gradle 2.0. And then when I say we introduce new features, in like I think 1.4 we introduced parallel builds. So now suddenly your build can run in multiple threads at the same time. So that's a big new feature, but we introduced that in 1.x on the side. So if you use that, of course you have to use the latest Gradle version, but if you don't use that parallel feature, everything that worked in 1.0 will still work today. So latest version that we are going to use today is Gradle 1.6. Was released about a month ago. That's the latest release, and of course that's what we're going to use in the workshop. And so we're already working heavily on 1.7. Might get a little bit delayed due to the summit, but somewhere in a few weeks after the summit, 1.7 will come out. Okay, so how far have the zips traveled down the road? Anyone seen the stick yet? So who has the zip file? Not so many. Third row doesn't look so great. And do you have it? You have it? Do you have it? Okay. Anyone who wants to do the labs? That's a good question. Anyone who wants to do the labs and doesn't have the zip distribution yet? The 50 max, 1 zip file? Anyone? Otherwise, let me know. Other good way is to pair with someone. As I said, you will be the winners, the pairs. I can tell you up front. Okay, so with that, let's get to the first lab, which is just to get Gradle running. For those of you who are interested in doing the labs, and I do recommend it, let's spend some time on that. So if you unzip that distribution, this is what you'll find. You'll find Gradle itself in there, and you'll find lots of labs with instructions. So if we go into labs 1.0 setup, and you should be able to do that on your machine in the zip file, have a look at the instructions there. And the first one, setup, that's just about setting up Gradle. So what are we going to do? There's this Gradle zip contained in the zip I gave you, and you just extract that into some convenient location. So you extract the Gradle distribution. And then there's really only one thing to do, more or less. You set an environment variable, Gradle_home, and you set that to the directory that you just unzipped, to the Gradle directory, Gradle_home. And so on Unix, you would do an export somewhere in your in the shell or something, and in Windows you can do it under system preferences, right? Set an environment variable. And the second thing is you add Gradle_home/bin to your path, so that we can run the Gradle binaries. So first you declare Gradle_home, and then you set Gradle_home/bin to your path. You add that. So in Windows you would have to say %Gradle_home%, right? And on Mac or Linux you would have to say $Gradle_home/bin to your path. And by then you should be able to run Gradle from the command line. So you need to open your command prompt or terminal and run the Gradle command. And what you should be able to do, you should be able to run Gradle-V for version, and you should get some version information. That's the objective of this exercise, running Gradle-V and getting the version printed out. Optionally, you can also set a Gradle_opts and set it to this value, and that's optional, but if you do that, Gradle will be much snappier. It will start much quicker. So if you feel cool with setting another environment variable, I do recommend you also set Gradle_opts in addition to Gradle_home and set it to this value -d org.gradle.daemon equals true, and then Gradle will stay active in the background and doesn't have to start every time you run a Gradle command, and so it will be much snappier. So I recommend to do that as well. And if you're already done, then have a look at the Gradle homepage /downloads to get an idea what kind of distributions we provide. And please, if you have any problem setting the environment variable or anything, then let me know immediately and we'll fix it. So with that, that's the first lab, getting Gradle up and running. Hi. Are you doing the labs? Are you intending to do the labs?
Yes, absolutely.
So everything is contained in here, it's one zip file. It's pretty large, but shouldn't be a problem. And you just unzip that, and then you get what I have on the screen. Anyone I can help? As soon as you get some error message, stack trace, or anything, it's time to raise your hand. So in terms of tools, you need the command prompt or terminal of your choice and the text editor of your choice. We are not doing IDE today, right? There is an IDE talk tomorrow, but today we will keep it simple, text editor and terminal. That's what we are going to use in the labs. Should I increase the font size a little bit? Can you read it from the back? Or should we make it a little bit bigger, maybe? If you're already done, look at the downloads page and check out what kind of downloads we have. We also have nightlies, we have release candidates, so you can always try the latest and greatest Gradle. You can try the 1.7 that's upcoming. Depends on what shell you have. I'm sure you're using C shell. I don't know what is the C shell. So you just export here and things should work. So you just have to get this. Using this. Who was the first one who's Gradle running? Sees a version? Wow, many people already. I'm not used to that. When I do this in Europe, I spend the first half hour on setting up environment variables. So I'm impressed. Yeah, if you already have, if I didn't mention that, if you already have 1.6 installed, and if Gradle-V works from terminal, that's a success criteria. If that works, then you are done with this first lab. Gradle-V should work from the terminal. Okay, let's give it 2 or 3 more minutes, because this lab is really important, because if you don't complete this one, it will be difficult to complete the next one. Anyone I can help? I'm here to care. Okay, let's give it 1 or 2 more minutes, because it's really important to get it right. Also, if you have time, set the Gradle_opts. You will be a lot happier running Gradle from the command line if you say set Gradle_opts, second environment variable to -d org.gradle.daemon equals true. It will make it so much snappier. Almost no startup time. We have lots of Macs here. It's almost like, do they give out a Mac for free here? It's like I can't almost, okay, they have a 1, 2, 3. Wow. That makes my job easier because I tend to forget how to set environment variables on Windows. I haven't used it in a while. Okay, last call. Anyone needs a pair to get Gradle set up? Yeah. I'm very grateful if someone says yes, because then I know you're reacting.
Did you set the middle? Did you ask me that? This step middle. Okay, did you see some output? Gradle -v.
So you needed to unzip that Gradle distribution, right? I hope I was clear on that, the instruction. So I gave you a zip. If you unzip that, you get that thing. There is the Gradle distribution. Unzip that again, and then set Gradle home to that. So I hope you figured that out. So let me try myself. If I do Gradle-V, then I get this. Gradle version uses this GUI, this IV. So if you see this, then you're set up. If you don't see this, raise your hand one last time. Okay, so I'll assume everyone who's keen to do the labs has been successful in setting it up. Okay, so let's continue. Actually, we immediately do our first hands-on lab immediately. So we go to O2 Quick Start. So you go to the O2 directory Quick Start, and again open the instructions. You have it on your machine, right? So here's the idea: go to the Gradle distribution wherever you unzipped it, your Gradle home, and I said it contains a lot of samples, right? So on your terminal, go to samples Java Quick Start. And that's the first simple Java bit. So go to wherever you unzipped the Gradle distribution /samples Java Quick Start. Then the idea is to play around with the Gradle command. Type such things as Gradle help and Gradle tasks and see what it tells you about that build. Thanks. Next, the idea is this Java build builds one jar file. That's what it does, one jar file. So try to figure out how to tell Gradle how to build that jar file. Maybe Gradle tasks will give a hint. So try to build that archive and try to see where it puts it on disk. So look where Gradle puts that jar on disk. And then if you have time and if you by coincidence have Eclipse or IDEA installed, you can run Gradle Eclipse or Gradle IDEA, and this will generate the IDE project files, and you can open it in your IDE if you have time and if you happen to have the IDE installed. These are optional exercises. And if you do the optional exercises, note the hint here. If you want to do the IntelliJ hint thing, then read the hint. And with that, I'll do it a little bit along with you. So let me see. Go on my Gradle home. And if you go into this quick start, you'll see a build.gradle. That's your Gradle build script. That's Gradle's POM.xml or Gradle's build.xml. That build.gradle. And if you're interested, you can have a look at it. It's not necessary for this exercise, but this is what it looks like. So it's a Java, it builds a jar and has medium complexity. It already does a few things. It has some external dependencies, grabs some stuff from Maven Central, configures the tests, sets some system properties for the test. So it's already non-trivial. It customizes the jar's manifest, but the exercise is not to understand exactly what we do here. It's just to seeing your first Gradle build script maybe, and to run it from the command line, right? So try to find the right Gradle command to execute that build and to build the jar. Yes?
Yeah, I don't think I have to be Gradle homework, even though I'm running version, it's just no samples.
So you have it running, but you don't see the samples?
Well,
This is easy to do.
I don't have samples. This is what
I saw that once before where something went wrong during the unzip. I had that once, so maybe let's try to unzip it
start
again.
over again. Yeah, I used to. Okay. I was trying to do it again.
Yeah, I've seen that before once or twice, so maybe it's as simple as that. Yeah.
So let's say
Yeah, you don't have to. If you can run Gradle from the terminal, then you're fine. Yeah, the samples we have to get from stick. Sorry, samples are on the stick, not in the distribution.
So are they in that? Because I opened the 3-hour workshop.
Yeah.
That's all I have.
No, it's in the lab. Now what are we talking about? So labs, okay, that's okay, yeah. And then the instruction, sorry. The instruction says you should go, yeah, so go open back yeah, so you probably install the whirlwind already because they install. So the Gradle stick that's on my stick, that's the Gradle solution. And that has a
It'll read this one.
so I'm sorry for that. So we have it now? Under the Gradle Summit.
Yes, I've got all this stuff.
So has anyone already built the jar and found it on disk? Anyone?
Yep.
Couple of hands.
You said a quick start.
Yes, so
I'm not seeing quick start directly in the samples.
no, so in the samples there's the full Gradle distribution that you unzip your Gradle home, and that in that Gradle home the Gradle distribution contains that samples directory.
I see that samples.
Yes.
Okay, samples.
Samples Java quick start. So usually we'll do everything in the labs, but just this quick start labs that redirects you to Gradle home samples Java quick start. So in this lab we play with one of the samples that come with the Gradle distribution. The other labs will be more self-contained. Yes. That sounds you kind of makes sense that you have this. So this one thing, this is one of the few labs where we need internet access. This one needs internet access because it downloads this third-party library. Most of the other exercises don't need internet, but to run this quick start example, to build that, you need to be able to access the internet. So maybe check your browser, it should work. Hopefully every one of you should have internet access. It won't be a problem for most of the other exercises. More or less, yeah. So everything that we will release is going to be all the defaults are if you leave all the defaults, it will look where the build located, and that's the project directory, and so the default is that the source resources are the source name Java relative to the project directory, and project directory is where the Gradle is. So the settings.gradle you don't only need for multi-project builds. There's also some use for single project builds, but it's for single project builds which only have single build.gradle settings. Gradle is optional.
So it's almost go like
it's completely yeah, the name of the build.gradle name has to be always written there. Whereas if you have a settings Gradle, you can do a rename the build.gradle. But Gradle is simply a bootstrap mechanism where it searches for an initial settings Gradle or build.gradle. And everything else follows from that. So in this case, it doesn't find a settings Gradle, but it instead it finds a build.gradle. And then everything else follows from that. And since in the build script we didn't reconfigure the source directories, it has a default for that. And default is source main Java resources. That's recorded relative to the project directory, which defaults to the single directory.
And the other thing is, if I run this, it seems
yeah, you have to all those files and the dot, so you have to do a ls-al.
Oh.
So that's why I got pass path and dot settings and dot project, I believe. These are the files generated. Now you should be able to import existing project into Eclipse. Okay, how are you doing? Who's had some success with this? Some success?
It's just a single jar file, right?
Yes.
And it says plural and it says archives and that kind of thing.
Yeah, because there is a task. You can say Gradle build archives. In this case, it will only be a single one, but it could potentially be more than one.
Trick question.
So, basically the idea was to cd to that directory, then do things like Gradle help, or there's also a -h, and there will, for example, see all the command line arguments. And then if you come to a new build that you haven't seen before, Gradle tasks is really helpful because it will tell you the tasks that this build provides. And this is a Java library build, and this is the kind of tasks that you get. The build tasks are the most interesting in our case. Yeah, move that a little bit. So you see here, for example, Gradle assemble assembles the outputs. So Gradle assemble would work. The overall task is always Gradle build. So Gradle build means more or less do everything, more or less. So with Gradle build, you're on the safe side. If you do Gradle build, you could also do Gradle jar, for example, because we know that it builds a jar. It will run then, and the question is where does it put it? And the answer is that by default, everything that Gradle produces goes under a directory called build. Everything's reconfigurable, but that's a default. And if we look further, since this is a Java library, it puts it under build libs. And here is our jar. And again, even the name, everything is a default. So our top directory is quick start. We didn't set an explicit, didn't give the project an explicit name, so it defaults to the directory. And that also makes it into the jar. So the jar is named after the project, which is by default named after the directory. So lots of conventions. If you come from Maven, you're familiar with that, and we like that. The big difference is that in Gradle, pretty much everything is reconfigurable if you have a need to. But you shouldn't do it just for the fun of it, because actually we follow the Maven conventions quite a lot, and we like them. But there are cases where they are not a good fit, and in Gradle it's always easy to reconfigure things. That's a difference in philosophy between Maven and Gradle. Okay. Yes?
So how the group ID is now? Like I see the artifact ID as a start. So if you come back.
Okay, so if we have a quick look at the build script, let me see. So the version comes from here. We set a version here. We didn't set a group ID, but the group ID would only be relevant if we publish to a Maven repository, and then we would have to provide that. So for example, as easy ways, there's also a group property. You say group equals something, and that will be that will become the Maven group ID. Okay, so I hope you had a first chance to invoke some Gradle commands. maybe I can take you quickly through the build script just to get a first idea. It already is a little bit non-trivial, but the interesting part is here. If you see, it has some Java code, right? Under source main Java, that's what we are building. And this Java code uses some external dependencies. And we'll talk about that later, but in a nutshell, we say that Gradle should fetch all external dependencies from the Maven Central repository. And then here in the dependencies block, this is where we declare the dependencies. And here we declare a compile dependency on the commons collections library and a test compile dependency on JUnit. But we'll have more to say on that when we talk about dependency management. So that's kind of these two blocks, repositories and dependencies, you will see in many Gradle build scripts. Because nowadays everything you build mostly depends on something from the outer world. So just to get a quick idea. But we'll have more details on these things soon. Okay, so let's move on to Gradle build script basics. So what's a Gradle build script? Ultimately, Gradle is built on top of the Groovy scripting languages. And for those of you who already stayed in the same room in the morning, I did the Groovy for Gradle introduction to get you up on speed with Groovy. Now it's not, if you're a Gradle user, you don't necessarily have to learn Groovy, but if you're a Gradle build master and want to author non-trivial builds and want to get the most out of Gradle as an author of builds, not as a user, then it's very helpful to have a working knowledge of Groovy. So if you have the build master role and want to do non-trivial stuff and want to push automation to the limits with Gradle, I encourage you to invest some time into learning Groovy, and it will be well spent. If you are only a user, just run the commands, maybe tweak the build script a little bit, bump the version from 1.0 to 2.0, then you don't need to know a whole lot about Groovy. But if you want to really understand Gradle under the hood, then you have to have some working knowledge of Groovy. So the question here is, how does Gradle relate to Groovy? Well, each Gradle build script, like the one you saw in the quick start exercise, is actually Groovy code. Although it looks quite declarative, like the repositories block and the dependencies block, actually it's valid Groovy syntax. So the way this works is that when you run the build, Gradle will, Maven would pass the POM XML to get all the information it needs, right? And Gradle, instead of passing the POM XML, it evaluates that Groovy script. And otherwise, it's very similar in that after Gradle has evaluated that Groovy script, it has all the information it needs about the build. So after it has evaluated that, it knows what the repositories are, what dependencies are, that you want to add some custom attribute to your jar. It knows all of that. It builds a data structure. Like Maven builds a data structure out of the POM, Gradle builds a data structure out of their build script. Pure data structure with all the information it needs. And only then, in the second phase, Gradle will actually run the build and execute stuff. So only after it has evaluated that build script, knows everything it needs to know, then it will do the real work, like compiling your code, grading your jar, and running your tests. So there's this two-phase approach in Gradle, where first it evaluates your build script, like Maven would pass your POM, and in the second phase it does the real work, like compiling your code, grading your archives, or running your tests. So the question here is, would this be a valid Gradle build script, like just this one line here? In Gradle you can really have build scripts which are one-liner and which do useful work. That's hard to believe when you come from Daemon. Sorry for that. But here we have a Groovy build script which we say the build.gradle just contains this one line. And the question is it a valid Gradle build script? And the answer is it isn't, because this is not valid Groovy syntax. This is print line is short for system out print line, and this is a string, but we forgot the closing quote, the single quote. So the Groovy parser won't be happy with that. It's like if you have a syntax error in your Maven POM, then the Maven POM parser will blow up. And same thing here, if you forget the closing quote, then Groovy will not be happy with that, and you will actually get an error message from Gradle will wrap it, but essentially the Groovy parser will complain here. So not a valid Gradle build script. Second line, let's say we have a build.gradle which just contains this one line, already looks a lot better. That's valid Groovy syntax. So you have system out print line, and what you want to print out is the zip code variable. there's only one problem. Gradle doesn't know about a zip code. So by default, Gradle doesn't know the concept of zip code. So the build will blow up at runtime and tell you, I cannot resolve the variable zip code. No idea what you mean by that. But it's a different class of error because syntactically it's correct. Also in plain Groovy, if you run that in plain Groovy, it will fail the same, and Groovy will say, I don't know what zip code is, maybe you forgot to declare it, that kind of thing. And now it gets interesting, the last line. Is that a valid Groovy program, and is it a valid Gradle build script? Well, if you run that in plain Groovy, in a plain Groovy program, it will fail because it will say the same thing as here. It will say, okay, I understand you want to print out a name, but I can't find a variable called name. So either you forgot to declare it or not. But the interesting thing is this is a valid Gradle build script, just as the single line print line name. It's probably not the most useful Gradle build script in this world, but it's valid. And the interesting thing is that Gradle understands name, because every build script is runs in a context. So like your JavaScript in the browser runs in the context of the DOM and can read the POM and write the POM, DOM, sorry. Your JavaScript, has a DOM that it can in the browser. Gradle has an object model, a plain Pojo object model that you can use from your build script. And the base entry point into that object model is that interface here, or Gradle API project. So you can look that up in the DSL reference. And when you look that up in a DSL reference, it will tell you exactly what you are allowed at the top to write at the top level of a Gradle build script. And if you look, DSL reference project has a name. That's the name of the project that you want to build. And that's why this println name is short for println project.name, and that makes a valid Gradle build script. It will print out the name of the project that you are about to build. That's all it does. And it's similar to JavaScript in the browser to JavaScript without the browser. So if you write some JavaScript that uses the browser DOM, then you can only run it in the browser, and you cannot run it standalone. Same thing is here. This Gradle build script needs the Gradle object model, so you can run it as a Gradle build script, but you can't run it as plain Groovy because plain Groovy doesn't know about the Gradle object model. So here we go, our first build script, print line name. We already activated the Gradle Daemon, or some of you. That was one way, the best way for our labs here is to set an environment variable, and that just starts a background process that stays warm in the background and runs all your builds. So now Gradle no longer has to fire up a new JVM, load all the libraries every time you call it from the command line. So it's a pure performance optimization. And right now it's mostly about startup time and keeping the JVM warm, the code chilled. But in the future, we have plans to use that for many other things. Like modern browsers, for example, they already prefetch the links, right, of the current web page. So just in case, if you would navigate there, they have already downloaded it. And likewise, we have similar visions for the Gradle Daemon. For example, we could already download the dependencies specified in the build script before you run the build. Because probably at some point you will run them and you will need them. Things like that. Yes?
I was just wondering, so when you go ahead and you set the Daemon like that, is there a way you can specify the options on like what it's going to use for memory and keeping that?
Yeah, in Gradle Ops allows you also to set some of those things, but there are pretty good defaults there. But you can tweak it a little bit by setting other Gradle Ops and pass in the regular JVM arguments, the -xmx and so on, and it will do that. Should it ever be necessary to stop the Gradle Daemon, you can do Gradle --stop. Shouldn't be necessary so often. However, currently we recommend to use the Gradle Daemon for developers, but not for your CI servers. Because for the CI server, it's not such big of a deal, and stability is more important. And the Gradle Daemon is a little bit like a server container. So it runs very, very, very long, so it can leak memory. If some of the plugins misbehaves, it can leak memory. Also on Windows, it's pretty hard to deal with file locks and everything with JVMs. So it's generally quite stable. I run it for days and weeks without restarting it. But even if it fails like once per month on your CI server, you don't want in the middle of the night find the CI server and run Gradle --stop there. So currently we recommend all users to use the Gradle Daemon, but not your CI servers. Okay, actually I think most of us already did the daemon setup. That was just this setting the Gradle ops to -d org.gradle.daemon = true. So we can skip that exercise and move right on to the first beefy topic. So Gradle is composed of multiple layers. So you can do low-level builds with Gradle, and you can high-level declarative builds. And in a nutshell, the low level is a bit comparable to the AND layer. So where in AND you explicitly declare all the targets and their dependencies, there's something similar in Gradle. And then Gradle adds another layer on top of that, the layer of Gradle plugins, which is more like the Maven layer, which is more declarative, where you say the what and Gradle figures out the how. So there's a lower task level and a higher plugin layer in Gradle. And we'll start with the lower layer, which is the task layer, because that's that's what eventually does the heavy lifting, the tasks. So that's what we have a look at first. Okay, so tasks are a basic unit of work in Gradle. Whenever you invoke something from the command line, like the Gradle build you invoked or Gradle tasks, that's always a task. You configure them, you declare them, and Gradle executes them. And this is again a build script. So in your build.gradle, that already makes, if you put that in your build.gradle, that makes a valid Gradle build script. And let's look at this in a bit more detail. So you want to declare a new task from scratch here. So we are not using the Java plugin yet, we're doing it the hard way. We create a new build from scratch without using any of the built-ins. So we declare a hello world task, and what we want to do is, whenever we call that task, we want to Gradle print out something to the console. So this is the syntax. There's the task keyword. You follow that up with an arbitrary name. That becomes the name of your task. And then you have the open curly, and everything that goes in here configures the task. So you declare the task with the task keyword, open curly, and in here you configure the task. When Gradle evaluates that build script, it doesn't run it yet. As I said, Gradle build is always two phases. First phase just evaluates the build script, similar as Maven passing the POM, and it just learns about that thing. And only then in the second phase, it makes up its mind whether it actually wants to execute that task or not. So in this first phase, it would learn, okay, I'm supposed to add a task named Hello World, and this is its configuration. And when I say configuration, this is a very special one, this doLast method, that comes from the task interface, because whenever you configure a task, that corresponds to a task object in the Gradle codebase. So again, you could look up task in the DSL reference, and you would find all the things you can say in this block, all the ways in which you can configure a task that you find in the DSL reference if you look for task. And one of the things that you can configure about the task, you can tell it what to do. That's a very fundamental thing. So in real world, many Gradle tasks already come with some functionality. For example, we ship lots of tasks out of the box. We ship a copy task and a jar task and a compiled Java task and a test task, and they already know what to do. But here we are creating a task from scratch, an empty one. And so we have to tell it what to do. And the way you do this is you use this doLast here, and again a code block, and in here can come any Groovy code, anything. And this is how you give this task a behavior. Again, in the real world, more often you're reusing an existing task that ships with Gradle, a copy task or a jar task or a compile task. But if you want to create a new task from scratch, right in your build script, this is a syntax. doLast, and in here comes any Groovy code and in a number of statements. In this case, it's just a print line. That's Groovy short line for system out print line. It's Java system out print line. And then in Groovy, you can also leave out the parents. So that's a method call to the system out print line method that takes one argument, which is the string. For those of you who haven't seen Groovy before. Yeah, so now you can say Gradle tasks on the command line, and it will tell you that this build has a hello world task. And then you can execute it by saying Gradle hello world on the command line, and then it will run it. And running it means executing that code here. So whenever you say Gradle hello world, you should see hello world on the command line. So a little bit more about this doLast thing. The conceptual model is that each task has a list of actions. It's a plain list of actions, and whenever you execute the task, it will execute all the actions one after another. That's the model. You cannot execute an action on its own, you can only execute a whole task, and it will simply look which actions do I have and will run them one after another. And so this is why you have a doLast and doFirst method, because you can add a new action on the front of that list of actions or the end. Say you have a task and someone else already added some actions and you want to add one more. Then it makes a difference. If you add one more action with doFirst, then you add it before the other guy's actions, and if you add it with doLast, you add it at the end. So basically you can decorate an existing task with additional behavior. Question?
Yeah, so you can't really test anything finer granularity than the task. I mean,
You cannot execute anything with finer granularity as the task. That's correct.
So you can't test it independently of the task. You can't, there's no real way to test it first by itself.
Yeah, no good way. That's correct. So very often you just add one task action, then it doesn't matter whether you use do last, do first. The only real use case where you want multiple is when you use an existing task, like you have this Java compile task that ships with Gradle, and that already has a task action, namely to compile your code. And now for whatever reason you want to do a little bit of logic immediately before the compiling or immediately after. Then you go in and to the existing Java compile task add a little do last or do first snippet. So that's the main use case. Otherwise, 95% of all Gradle tasks in the real world build have just a single task action. And usually you don't code it yourself because you just use the Java compile task or the jar task. But sometimes it can be useful to do some ad hoc scripting in the build script, and this is how you do it. So I already said, as soon as you declare a task, you can execute it by its name. So if you have a heavy AND background, the way you can think about a Gradle task is the fusion of an AND target and an AND task. So you can call a task from the command line, you can execute it like an AND target. A task can have dependencies on other tasks, like AND targets can have dependencies. But a Gradle task also has behavior. In AND, the target doesn't have behavior, but the AND task has the behavior. So if you put the AND target and task together, then you get a Gradle task that has behavior, can have dependencies, and can be executed straight from the command line. That's how to think of it if you have a strong AND background. There are lots of nifty features around task execution. One of them is we always have this philosophy, you should treat your build script like production code. Everything that applies to writing good production code applies to writing good build scripts. So for example, you should use descriptive names. You should keep it simple, keep it dry, don't repeat yourself. You should factor out common information and not repeat it and copy and paste it. And one of those things is good naming, so you should give really good names to your tasks. The only problem with that is if you use a really good name for your task, it will be harder to invoke from the command line because it gets that much longer. And that's why we have this feature. You can abbreviate task names on the command line. So here I'm trying to call, for example, this some other task here. I can spell it out fully, but also I can do this camel case abbreviation that you may know from your IDEs when you search for a class. So instead of Gradle some other task, I can write Gradle S other T or even Gradle SOT. And if that's not ambiguous, if it can expand it to a declared task, it will run it. If it's ambiguous, it will tell you, I don't know what you mean. And this you can use in quite a few places. So here we use the -x to exclude subtask. And the infamous example here is, which everyone is told he should never do, but everyone has done it before, is Gradle build -x test. I want to build it, but not run my tests, right? And even if you exclude the test, so here we run some other task which depends on this one, so it would execute both of them, but we don't really want to execute that one, so we say -x, and even there we can use the abbreviation. So my name is pretty long, is abbreviated to that thing here. That's just a small nifty feature that gives you both the best worlds. You can use long descriptive names in your build script, but it's still fairly easy to invoke it from the command line. Okay, now we have tasks, and those tasks have a behavior. Now, often tasks depend on each other. The same thing as in AND, where targets depend on each other. What does it mean? So we have two tasks here. We declare a task foo. By the way, that's already a valid Gradle build script. If your build.gradle only contains task foo, Gradle is fine with that. You can type Gradle tasks, and it will tell you I have a task foo. You can run it, and Gradle will say build successful. It will not do anything, because if you declare this thing on its own, it has 0 task actions. So Gradle will execute it, and executing it means doing nothing. But Gradle will be completely happy about that. And then we add another task bar, and now we want to add a dependency. So we want to say that bar depends on foo. And what this really means, when would you add such a dependency? Bar depends on foo. It means that foo produces something, some files or something else, that bar desperately needs. So foo produces something that bar consumes. That's the only good reason why you should add a task dependency. One example is in the Java project, you have a compiled Java task that compiles the code, and you have a jar task that jars it up. And so obviously the jar task needs the class files to jar them up. So you have a dependency, jar depends on compiled Java. And that means whenever you run jar, it will first run compile Java, create the class files, and then jar will package them up. So here, compile Java produces something, the class files, that the jar task consumes. And this is when you should add, it's really a semantic relationship. You shouldn't think about it, this should run before that. You should think about it, and this task needs something from the other task. That's when you should add a dependency. And syntactically, we follow the Groovy model, so there are a few ways to set that. There is like the Java API way. You call the depends on method on the bar task and pass in foo, and that sets up this dependency. And again, where does this depends on method come from? You find it in the DSL reference. You go to the task, and task will list, the task interface will list all the methods and properties, and depends on is one of them. But there are also some other variations. Like, for example, you can say bar open curly, and everything you say in there, everything in there configures the task. So in this block, you don't have to say bar dot anymore. So the second line, this syntax is very handy if you want to configure many things about that bar task. Because you could say bar dot, or you say bar open curly, and anything you say in there is relative to the bar task, so to speak. So that's the syntax you often see. There's another syntax for historical reasons. That's name parameter syntax, but I would rather recommend to use the last line for a one-liner. And if you want to configure multiple things about a task, then task name, open curly, and then anything you need to configure about the task goes in there. So far we've worked with ad hoc tasks that had no behavior on their own. We just added some. But in the real world, you will more often reuse an existing Gradle behavior, a task type. So for example, if you need to copy some files, Gradle already ships with a task to do that. And this is how you say that you want to have a task that has copy behavior. So again, you use the task keyword, you declare a new task, you call it, for example, copy files, and then the different thing here is now you give it a type. In Groovy, that's a name parameter, that's the name of the parameter, and that's the value, and it's separated by a colon. So you say the type of that task is copy, and copy is simply a class from the Gradle API. So if you again look into the DSL reference, or even the Gradle code base, you will find a class called copy. And that class already contains all the behavior of a copy task and the API necessary. So it knows how to copy, and it gives you a way to tell it what to copy. Everything is contained in that class. And so you say task copy files, type copy, open curly, and in here again you configure it. Because for example, for a copy task, there are two important pieces of information it needs. In particular the copy task. It needs to know one or more sources of the copy operation and the target directory. That's the minimum information it needs. And that's what you can tell it inside here. Inside the code block, you tell it that. Copy from this directory to that directory, for example, or copy this file to here. You tell it in that block. So here we have another example. So you say task copy, and that's not so important right now, but the way how you tell the copy task, what the sources of the copy operation, you use the from method. So from SUMDIR would copy that whole directory recursively, and then you have to tell it the target. There is an into method. So you would add after the from into some other directory, and that, for example, from SUMDIR into other dir, and that would recursively copy everything under SUMDIR into that other dir. So that's a two-liner, and already recursively copies something from A to B. And you would then on the command line say Gradle copy, and it would execute it. The idea of this slide here is that some configuration options are available for all tasks. So no matter what their type is, or if they have a type at all, some things you can configure about all tasks that you will find in the DSL reference on the task interface. And some things you can configure are specific to a particular task type. So only a copy task has this concept of source and destination. So this from and the into are only available for inside a task of type copy. Whereas these methods, the do first you already saw, and only if is another example where you can conditionally execute a task. These are understood by all tasks, no matter what their type is. Yes?
Some way you get Gradle to tell us what all the types are that I can choose from? Or
yeah, that's a DSL reference, first page. And on the left bar, you see task types, and that's a list of all the tasks that ship with Gradle. Okay, Now the question is, how is this, for example, this copy implemented in the, this is a class, right, a regular Java or Groovy class. How is that implemented, and could you do that yourself? And the answer is, if you want to write a custom task and want to reuse that in many places, not just in one build script, because if you want to reuse something just in one build script, you just do task hello, do first, and code script something up here. But that's not very reusable. If you have some custom logic and want to reuse it multiple times in the same build, or even in all builds in your enterprise, then it's more convenient to write it as a task class, like copy, but copy already ships with Gradle. And here's an example of what that looks like. Here we write, let's say we write an FTP task. We want to have this FTP functionality available, and this is how you write it. You can write the task class in plain Java, if you prefer that, or you can write it in any other JVM language, like Groovy. Groovy is kind of a natural choice, but all Gradle APIs are designed in such a way that you can use all Gradle features from plain Java, as soon as you are outside the build script, right? So it's a matter of preference. In this case, we write it in Groovy. If you know Java, you see the syntax of Groovy is very similar to that of Java. So we create a class FTP task. We extend some Gradle base class that makes it easier for us to implement that task. And then we have two important bits of information. The FTP task probably needs some configuration, like what's the destination of the FTP operation, and that you do by declare some fields. Actually, in Groovy, these are properties, but these are very similar to fields in the Java class. So by declaring a host and giving it some default value, the user will be able to declare the host for his FTP task. And if he doesn't declare it, he will get this default value. So that's the one thing. That's whatever the user should be able to configure about your task, you put it in here as Groovy properties or Java fields with a getter and setter. And the other important piece of information is the action, namely how to copy something. You have to teach the task how it actually does FTP, right? And this is how you do it. You write some public method. Can you name it anything? You implement here the functionality. So here you have to implement FTP by hand or use some other FTP library. You will probably, for your implementation of the FTP task, use that information, what's the destination host. And then the important missing bit is you annotate it with add task action. That is an annotation that comes from the Gradle APIs, and this is how Gradle knows whenever I should execute such a task, I need to execute this method. Because you can put in any number of methods as you like, just for coding reasons, but one of these methods needs to be the entry point, and that's simply done by annotating it with add task action. And for the purpose, we will have an exercise soon where you will write such a class, and you can do all of that right in your build.gradle. That's not necessarily how you do it in the real world, but for our labs, if you are asked to write a class, just put it straight into the build.gradle, the class declaration, and then you can reuse it from the same build.gradle. So for the purpose of our labs, this is perfect. We don't need separate files or anything. Okay, that gets us to the next lab. And we experiment with declaring some tasks on our own. So have a look into 04, custom tasks, build.gradle, and you will add all your code in this build.gradle. And the instruction is also inlined here, right? So you read the instruction and then code that up in the rest of the build script. So what are you supposed to do? Write a custom task class of type greeting that will be very similar to that FTP task class. Just that you should call it greeting. It should add a property greeting that tells it what greeting to use. Give it some default value, some default greeting, and then give it a task action, again very similar to the FTP task, that simply prints out that greeting text. And once you've written the class, you should add two tasks that reuse it. So you add two greeting tasks with different names. Both should have type greeting, and one of them should override the default greeting value. So one of them will use the default and the other one will override it. And then you should be able to execute both those tasks from the command line by saying Gradle task name. So that's the objective. And it might sound a bit daunting, but the good news is that it's very similar to like this FTP task class and everything you've seen. And by the way, you have the slides also on your machines, right? So if you need to go forth and back, then either do it on your machine. I unfortunately haven't figured out how to show many slides at once on my screen. But you can do so on your computer, or you can always check out the DSL reference as well. So let's give that a try, and if you have any questions or troubles, then just let me know.
syntax. So you can tell it use a main repository like this or that idle repository, or what we call use a flat here repository. That's the syntax. This also comes default. Yeah, so there are many ways to do it, because several ways to do it. One way is because we have the repositories block, there you flag your repositories, and then you add the dependencies block, and there you say I provide dependency on this or that, and if you look for that jar, you flag your repositories. The repositories block. In there you can reflect the repository. Remember the easiest way is to go to the user guide and then look for the dependency management chapter. And there as well some examples. And also the integration examples and something from some sources and dependency management blocks that can show that. So it should be okay. Yeah.
So I actually don't think you take one of them was so you want to add 10 chances. Yeah, so okay. One will have one time. Some people today.
Yeah, okay. Yeah.
That's not the repository. That's the repository always getting stuff. Or a package. That's the easiest way to get the first line there. Just say oh, that's all that oh. Yeah, so there's a lot done in here.
Okay, anyone got any questions on the lab? Yes.
Yeah, one thing is that here, yeah, it has to be in the semester. This is if you get in line in the build script, and you do it first. But here you're writing a class that covers, and that's the same thing. But here, that's how you add action writing a build script, and that's how you add it to write a class. Any method is for the same name, and you annotate it with any class action.
So I
but then here and rest is still we are already on Java, same syntax. You can call it. You can just copy the whole method down with the class page.
that's hard. Hey, what? There's code. What the hell is this?
now you suppose have three tasks of certain type. So this one this has no type. This is a default task. On one of the slides we have how you can declare a task with type like copy and your task is type read. And we have there something like this. This declares a task of type copy, and you will instead declare the task of type read.
Like I want to run it.
Something like that's how you say and you add two such tasks, and you have just to vary their names, like Gradle 1 and Gradle 2, and they both have the same. They both have the same type. That gives them their behavior, but they are separate tasks. Right? That was the idea. And then you should be able to call them from the command line. Any more questions? Everything you figure about the task for this Any more questions? Yes, now we're starting to.
So, this one is create tags.
Yeah, the thing is, I know, that's one thing. So you say you created the task of type read, right? So it already has that behavior. So in here you don't have in the block you just configure it. And the thing that's configurable about this particular task is a reading block. So you can override that. If you also have a call from in here, then whatever. So nobody ever called it explicitly except read. So in here instead you say if you are happy with the default reading, you can leave out the whole resources block. So remove it. That was the idea for one of the tasks. You don't have such a block. So after the closing parents, everything else goes away. And for the second task, you override the default value because let's say you're not happy with it. So you say greeting equals some other string. Yes. Here you have to
Oh, I don't have to do that.
No, you must not do that.
But how does Gradle, for example, Gradle creating one, then how come Gradle knows how to do this?
Because it's of type reading, and you have annotated, this method is annotated with a task action. So Gradle knows whenever it wishes to execute that task, it will call it method. But that decision you have to leave up to Gradle. So you just declare some tasks and leave it up to Gradle never to execute them. And you don't execute them like a method.
Okay, so I have next question. For example, I have another method. This is do grading, but maybe do something else.
Yeah, you don't really have that. Each task class has a single task action, that's its behavior. The combined task has, you can do it, it will work, but there's a use case behind it.
Oh, okay, yeah, that's my question. Actually, if I have multiple individual tasks, then how do I know like
It will run all of them, but the order will be random.
Right.
And that's why there's no
It's
use
going to be
case.
very confusing.
Yeah.
Oh, okay.
The only reason why you can have multiple actions
Yeah.
is, for example, someone else wrote the greeting task.
Yeah.
It's not under your control, but you want to use it in your script.
Yeah.
And then you want to, for some reason, you want to do a little bit of work just before the greeting or after.
Yeah.
And then you can in here add a do last to the first. But the task class itself will always have a single action.
What if I want to override this behavior? This function behavior?
You cannot easily override it. Either you are happy with the task class or not. You implement your own one. Usually there's no such reuse on that level or inheritance. It's usually not what you do. Exactly, yeah. The build script is all about configuring the properties. The build script itself doesn't run the task. So Gradle runs the build script just to learn, to get information. And then in the second phase, execution phase, then it looks at what you entered on the command line and figures out which subset of tasks to execute at which order. And it makes use of the information you provided. So it's a little bit more declarative. You never call a task from the build script, you just configure it.
Actually, I have another question. I assume this works, but then later on, I want to put this one. I want to put this class direction, definition into another class. But originally, I was doing on the class console.
I think it doesn't work for the apply from. Maybe we'll get to it. You have to move the class to some other place. So the apply from brings in some tasks and so on, but not your class. It's just a technical limitation together with Ruby. So you wouldn't typically put a task class into such an other build script. There are other places where you include the task classes if you want to move forward from the build script. I think we'll get to it. I hope you will. So one more question. Who's the one? Anyone else? Yeah, I think you were waiting. Right now, so you need to get a task type. Now you additionally have to declare one of the tasks. Like we had this on the slide, copy file, copy. So you declare a task, the task. Yes, the name of your task. No, the name of your task. And you have to use the task keyword. So these things are just configured something existing, which is actually in the you can see it when you use the idea was to declare two such tasks with different names, and one should set the reading numbers to something. Okay, I hope you had some success with this exercise. I think it's time to move on. Let's have a quick look at a potential solution. So that's how you could have done it. First, you brought this greeting class.
Oh, okay.
It has a task action, which is a method that just prints out the greeting, and it saves off the greeting introduced in a property or in a Java field. And we give that some default value so that if someone uses my greeting task and doesn't specify a greeting himself, it will print hello from Gradle. And once you have the task type, that's just the capability. Then you or someone else can declare tasks of that type. So more commonly, this is written by someone else, right? This ships with Gradle or is written by your build master. And then the users who are authoring the build, they just write in their build this part and declare some tasks which make use of that task type. And then we have one which doesn't override the greeting. So if we run Gradle default greeting from the command line, it will print out hello from Gradle. And if we run Gradle custom greeting from the command line, it will use that overridden value hello from me. So the important thing is here, these things just configure, they create a task and configure it. So you should never explicitly try to call this method from the build script. Instead, you just configure the task and Gradle figures out if and when to call that method. Okay. I hope you had some success with that. Let's see how we're doing in time. Do you know when the break is? Is it already 12:15? Okay. So let's see. 12:15. Yes. So we'll have our lunch break shortly. After the lunch break, we will continue 1:15 p.m. straight. And yeah, so maybe we only have like 4 minutes. So maybe let's use it for some questions if you have any at this point. Sorry. So do you have some questions? Some more questions?
So we can have more than one
Action.
We can have more than one activity.
In a task class, you can have it, but there's absolutely no use case for where it makes sense. So you should always only have one task action in a task class, because you can only execute a task as a whole, and then just write one action, and you can split the implementation of that up into multiple methods. The only reason why Gradle allows to have multiple actions is, for example, if this is written by your build master, this class, and you are reusing his work, right, in your build script. So you are writing for your build that thing. And now, for whatever reason, you want to do a little bit of work right before the greeting task runs or right after. You want to decorate the task. Then you could, in here, you could configure it further and say do last, and then add your own little bit of logic here. And so by that you make sure, now the task has 2 task actions. This is his main task action, and you added another one. So that's only really useful if someone else provides the main action and you want to add another one. But for the provider of the main action, there's absolutely no use case where he would add multiple task actions. And in fact, if you add multiple, they will be executed in a random order. You can't tell, because Gradle uses Java reflection to learn about these things. And so it lists these methods with this annotation, and Java reflection doesn't guarantee any order in which it returns them. So Gradle cannot figure out the declared order of these methods here. And also there's no use case behind it. So simply, if you write a task class, it should always have exactly one action. The reason why a task can have multiple is then if the user of your functionality wants to decorate a little bit. That's the only use case for this thing, having multiple actions in one task. Okay, other questions before lunch?
Will we access actions of the superclass?
Yes, again?
Is there a way to access actions of the superclass?
Not easily. So usually tasks are not a good fit for inheritance. So there's also no good way to override the task action of the parent. Well, if you override the method, that will work. Usually you don't do it. There's very little inheritance in Gradle task implementations. So we try to avoid it whenever we can. If you need this kind of thing, then you will implement that in such a way. So this task would use some other class which is designed for inheritance. And then the different tasks would rather reuse that common class than inherit from each other. That's the general answer. I mean, there are a few cases where we do it, but it's simple cases, I think, where this one introduced some abstract methods. So in the base class, you have some abstract methods. This implementation calls them, and the subclass provides implementation. So this, what is it called, the pattern? Template method. So that you see sometimes. But in general, most tasks, they don't extend from each other, but each task extends from default task. That works best. Anything else?
Can you pass multiple with the task?
Multiple
parameters? Like we have updating right now.
Yeah, so this the task can declare any number of properties, and you can then set all of them. It's just a matter of which properties are declared by the task. So I don't know, you could say string lunch equals yeah, and then you could print out here the lunch as well. And the implementer of the task class just needs to add the property, and he will get the build language for free. So now suddenly, in this block, we now suddenly can set a lunch. So that's how it works. It depends on what the implementer provides.
So if you give the parameters new values and variables new values, does that happen before
when you first happened?
Yes, exactly, because I said there are these two phases. First, Gradle evaluates your build script, learns about everything, and in the second phase it executes it. So actually the do last is also just learning. So at this point when Gradle evaluates the build script, and you add another printer here, it just learns that it should add a task of type greeting. That it does immediately to an object model. It adds an object of type task to its object model. Then it's really an instance of that class, right? It's like in a Java program. Then it sets that property here to hello, it sets that property to lunch, and then it saves off this code block for later execution. So then that if and when it decides to execute it, it will run this guy and also this guy. But it doesn't run it yet. And then it's at the end of the build script, and this first phase, we call it the configuration phase, has ended. And only then Gradle starts to look at the command line. So for example, if you type Gradle default greeting, it makes up an execution plan. So it looks at the task and the dependencies and makes up a plan. And then it transitions into the second phase, the execution phase, where it actually runs your tasks. And then if it decides to run the custom greeting task, then it will execute that code in the execution phase. But if you say Gradle default greeting from the command line, then this thing will not execute what's in as this code block here. If you say from the command line Gradle default greeting. Only if you run Gradle custom greeting, then it will eventually execute that code block.
So if I have a typo, let's say, print and then just print, or something like that, as a typo, it won't tell me at the configuration phase, it will tell me at that.
It will tell you in the configuration phase. So if you misspell the greeting, currently what you will get is a warning in big fat letters. We can't make it fail because in Gradle 1.0 it was so dynamic that if it couldn't find the variable, it was going like, oh, I think he wants to make up one on the fly. So it used to be like very Groovy dynamic. It's no longer that. But since we have this strict backwards compatibility, we cannot make Gradle 1.6 fail hard, but we print a big fat warning. And it says dynamic properties are deprecated, and in 2.0 will fail hard. And it's simply to make your life easier, because the Groovy folks love that. Oh, I can just invent things on the fly, but everyone else is like, I looking at an hour at this build script until I find my spelling mistake, you know. So the usability is a lot better now, but it's a warning. And as a general hint, if you get a warning from Gradle, very often it's really an error in disguise. It's like, I think something is wrong, but I'm not allowed to fail because I have to be backwards compatible with 1.0. So take the warning seriously that you get. And that will help you to find some spelling errors and so on. So with that, let's do lunch and let's be back in 1 hour straight. Thanks.